All right, welcome back. Today we're starting Unit 2, which is all about linear and exponential growth. We're going to talk about graphing a line. We're going to talk about looking at data in a table and determining whether it's linear or exponential. We're going to look at some graphs, and then we're going to get into some just real life applications of slope and equations of a line as we go through the unit. So we're going to go ahead and get started. This is going to be a little bit of a quicker unit. You do have some labs, so make sure that you get those labs knocked out. But think about, what is linear, what is exponential, and those are kind of the questions we're going to answer. We're going to work towards answering through this unit. Ask yourself questions like, did you add or subtract a common number between all the digits in the sequence? Did you multiply or divide by a certain number between each number in the sequence? If you can't answer yes to either of those questions, then your sequence is not linear or exponential, and we will see some examples of that. So we're just going to kick off and talk about linear patterns. In order to be a linear sequence, you are going to have to add the same number each time to get the number in the sequence. So this is really important. You're adding, okay? So to find if it's linear, okay, you need to subtract terms in the sequence to see if they are all the same number by following the formula next minus previous. Okay, so don't worry if this doesn't make sense. We're going to talk through this in a second. But remember that you're basically trying to figure out if you go from 1, 3, 5, well, I know very quickly in my head that I've added 2 each time, but I could also say that 5 minus 3 equals 2, and 3 minus 1 equals 2. So remember, this is your next minus your previous, and they always equal the same number. That's how I know it's linear. So let's talk about exponential pattern. So if you're an exponential pattern, you are going to multiply by the same number each time to get to the next term. To figure out if the sequence is exponential, you're actually going to use this formula, which is next over previous. Now, I made a really key statement in Unit 1, and I told you guys that when you see a fraction, so numerator over denominator, what does this fraction bar mean? It means division. And I made that comment because you're going to use that fact over and over and over again, okay? So when you see next over previous, that really means next divided by the previous, okay? So let's use these two rules, these two formulas, to look at the next few examples. So example 1, for each of the sequences, determine the type of pattern, list the next 3 terms, and then state the rule. This first one we did together, so first we need to figure out, is it a linear? If it is, then you don't need to check exponential. So we're going to start with our linear, so that's this next minus previous. So we're going to use that formula. So we did the next minus our previous, so 49 minus 45, and we got 4. We did 52 minus 49, so next minus previous, and we got 4. And then we did 56 minus 52, so next minus previous, and we got 4. Since each next minus previous gives us the same number, which is 4, we know it's linear. So what would the next 3 numbers in the sequence be? So let's figure that out. So if you look, the next 3 numbers in the sequence are going to be 60, 64, and 68. So all we said is we started with the last number we were given, and we added 4, because that's what we're doing every time. And this gave us 60. And we took 60, and we added our 4, and that gave us 64. And we took 64, and we added 4, because that's our rule, and we got 68. Ta-da! So therefore, this is a linear equation. We have added the same number every single time. All right, so now let's look at the next one. This is another example that's been worked out for you. So it already tells us no, but let's just try. So if we did 7.5 minus 3, we would get 4.5. Okay, so then if we did 18.75 minus 7.5, we would get 11.25. Well, I can already tell you that this is not linear because these two numbers are not the same. We can keep going and check, and that's a good idea. okay? So if it can't be linear, then we need to check to see if it's exponential. So that's what we've done here. We've used our next over previous formula. And so we've done this and we've said 7.5 divided by 3 gives us 2.5. And then we did 18.75 divided by 7.5 and we got 2.5. And then we did 46.88, and you're probably thinking that doesn't work, but it does, 18.75. And that also gave us 2.5. So because we got the same number by dividing the previous by the next, then this is exponential. And so if we want to find the next 3 sequences in the term, we would need to multiply each term by 2.5. So whatever number they have in common, that's what we're multiplying by. So we're doing inverses, so you can think of that. If you're adding to get the next term, then you're going to figure out what you're adding by subtracting. And if you are multiplying to get the next term in your sequence, then you need to divide the next and the previous to find out what you're multiplying by. Sounds confusing. Once you get the hang of it, it's not. So if we do multiply, we would take 46.88 and multiply it by 2.5, and then we would get 117.2, and then we would take that number, 117.2, and times it by 2.5, and we would get 293, and then we would take 293, and we would multiply that by 2.5, and that would give us 732.5, and that's how we got the next 3 numbers in our sequence. So therefore, it's exponential. So now let's run through some practice problems real quick. So we're going to do the same kind of thing, and we're going to work through them together. So this one, we're going to start with number 1, and we are going to look at this one and say, is it linear or exponential? So notice that the numbers are decreasing. So let's check it. So let's 32 minus 35 would give us -3, and then 29 minus 32 would give us -3, and then 26 minus 29 would give us -3. So since we're always subtracting, getting -3, that means each time we're going to add a -3. So to do that, let's do 26 minus 3, and that's going to give us 23. And we're going to do 23 minus 3, and that's going to give us 20. Then we're going to do 20 minus 3, and that's going to give us 17. Now you'll notice I said minus. So just as a quick reminder, when you have 26 plus -3, this is the same thing as 26 minus 3. Okay? As 26 minus 3. So I'm saying -3 just because I'm doing this process in my head, but definitely if you do 26 plus -3, you'll still get the same numbers each time. Our rule for this one, I'm going to put rule because I want us to get into this habit. Our rule for this one is -3, okay? And then it is linear because we're adding the same number, or in this case subtracting the same number every single time. So therefore it's linear. All right, let's try this next one. We have 12.5 minus 5 gives us 7.5. Then we have 31.25 minus 12.5 gives us 18.75. So I already know that these cannot be linear. That will not work. They're not the same number. So let's get rid of that. So we know if it's not linear, then we need to check exponential. So let's try that. So let's do next divided by previous. So 12.5 divided by 5 will give us 2.5. And then 31.25 divided by 12.5 gives us 2.5. And then 78.125 divided by 31.25 is going to give us 2.5. So now we have 2.5 as the result, and they all follow the same rule. So now our rule is that we multiply. So we're going to multiply by 2.5 each time. And so if we're multiplying, we know then that it's also exponential. So now let's find the next three terms in our sequence. So if we find the next three terms in our sequence, we are going to do 78.125 times 2.5, and that's going to equal 195.31. And then we're going to take that number, 195.31, we're going to multiply by 2.5, and that's going to give us 488.28. We're going to take that number, 488.28 times 2.5, and we are going to get 1,220.07. So I'm not going to attempt to write that in the three blanks here, but you would have these next three numbers. All right, so let's check the third one. So for number 3, we have 0369. So most of you can probably, just from practicing counting, do this in your head. But let's go through the exercise. So 3 minus 0 is 3. 6 minus 3 is 3. 9 minus 6 is 3. So since they are all the same number, this is linear. And so our rule is that we are adding by 3. And then because we're adding, it's linear. Okay? So now the next three numbers in our sequence, if I add 3 to 9, I'll get 12. If I take 12 and add 3, I'll get 15. And if I take 15 and add 3, I'll get 18. So the next three numbers are 3, 6, 9, 12, 15, 18. All right, here's a good stopping point.